Chapter.
Why don't you, Steve? Go ahead.
So we have an opportunity to partner with the Philadelphia chapter, and so what they're looking for is they'll help us with speakers and presentations and whatnot, and then we would reciprocate. So I know Ralph has indicated he has several types of presentations. I know Rob does. So I'm asking the membership, or do we want to do this, and can we support it with presentations?
Have they given you an idea of what kind of commitment they're looking at? 1 or 2, 3, 4?
Right now they went to their executive board, and I'm doing the same, if you will, to our membership. It's not been fleshed out as to, but I can tell you he's reaching out right now to Europe, to Australia, to all kinds of places, because we're all virtual. So there's a tremendous opportunity here to at least establish, like you were just mentioning, what others are doing and what we're seeing and how to move it forward.
Yep. Yeah, that ties into the ambassadorship program. So I personally think we should go forward with it. Does anyone else have an opinion on that matter?
Yeah, I think so too.
Okay.
It gives us an opportunity, some of the people that are local speakers, gives them an opportunity to speak at a different chapter and then get some of theirs to speak at ours, even if it's virtual.
Yeah, different audience. That'd be good.
And I would imagine something like that's going to be on the gold thing. You know, it'd be a good thing to put down that we
partner with other chapters. Yeah, because it was previously that they had partnering on conferences. So that'd be a good segue into that.
Okay. I know Ralph was on board with it. Correct me if I'm wrong, Ralph. And so if everybody's in agreement, I'll let them know and report back what we can get worked out.
Okay. Just writing some notes here.
Oh, sorry, no microphone for Ralph.
Yeah, Ralph doesn't have a microphone, so he can't chime in, but he can hear, so that's good.
Maybe Santa will bring him one.
All right. Well, I don't really have any other new business. If I can get a motion to close the business meeting, unless you guys want to keep it open
close
too. All right. Second. All in favor?
Aye.
Aye.
Perfect. The ayes have it. All right. So that ends our business meeting. Let's roll right into our presentation. And Steve, if you'd like to take lead on that, introduce our speaker. I'm going to go ahead and stop my video so I don't bog down the bandwidth here. You got the lead, Steve.
Okay. Hello, so our guest speaker tonight is Lee Kiser from OR Fire Protection, and he's going to be speaking to NFPA 75 criteria and some recent changes and maybe some things that will be coming in the future. So Lee, at this time, I'd like to turn it over to you.
Hey, thanks, Steve. I'm sure everybody can hear me. Wave if you can't. Thanks for this time. Yeah, I'm going to talk things surrounding NFPA 75 and fire protection for data centers and other IT spaces. I'm here kind of representing the Fire Suppression Systems Association. My day job is for OR Protection. I'm a fire protection engineer for them, and I live in Louisville, Kentucky. I'm chair of the NFPA 75 committee, so I'm pretty involved in data center fire protection. I sit on the FSSA technical committee, on a couple other NFPA committees. I'm on NFPA 200, which is a new committee where we're writing the standards for suppression system hanging and bracing, which is, we haven't actually had a lot of requirements for CO2 and clean agents and water mist systems. That's all kind of new. And so I sit on that technical committee. And then I'm also sitting on, I can't even remember the name. I think it's 99. I can't remember the number, but it's on remote inspections. So the inspection, testing, and maintenance side of what we do at OR is, I'm hoping with new opportunities and new technology to do more things remotely. So this presentation has been given several times in FSSA circles and really also at SFPE. It's been updated as things in the data center, the way we build data centers has changed, but it's fairly new information. It is, there are new things happening, and I would encourage any questions just as we go along. If you've got something that I've said that didn't make sense or something that is controversial, just please, let me know and let's talk about it. One of the reasons we have some new requirements for how we protect data centers is because the IT equipment that we're putting in them is changed significantly. A major thing is that there are higher rack power densities. So, racks are the big cabinets that we put the different server equipment in, and those pieces of equipment, as they are doing faster and faster computing and handling more data, they consume more power, and power equates to more requirements to cool that equipment. So because there's more need to have higher computing, leads to more power, leads to more cooling required. And so we're ultimately what's happening is those the rack densities are going up. It saves on the facility space, so we don't spread out that computing load over a larger square footage. It does support new technologies. There's a couple of words that we'll use as we go along here that are instances of that. And because there is a concentrated load, it can contribute to reduced energy costs, even though the overall energy usage is going up. So there are new cooling technologies that are being used in data centers to address these higher rack densities. That includes supporting high density computing and improving cooling efficiencies so that we get a better bang for our buck for that air that we have paid to cool. The result is it can challenge the performance of fire protection systems in those spaces, especially in older data centers where systems were put in at one time, and then over time the technology has improved, the rack densities have went up. It can challenge and certainly is challenging fire protection systems. Yeah, this is I want to talk about this phrase hot aisle, cold aisle, and we're going to talk about hot aisle, cold aisle, and then hot aisle, cold aisle containment, or just aisle containment. And it's the idea that on a rack, hopefully you can see my cursor here, there's a cool face of the server where cold air goes in, and then it picks up heat as it blows across the server, and then on the backside, that's the hot side of the rack. Well, when we arrange the cold sides facing each other, we make a cold aisleway. We can walk down this aisle, and that's the two cold faces facing together. Naturally, then if we keep doing that in repeating fashion, we're going to have the hot aisles facing each other. So that cold aisle, hot aisle, that wasn't always done in data centers. Now it's done now as one of, it's a fairly old step now for improving cooling efficiency and effectiveness of the cooling energy used in a data center. Now, we've stepped beyond that in many, many ways. So the traditional cooling approach for data centers was just allowing hot air and cold air to mix, using, this is a pretty good picture of that. and frankly, the other picture was too, having CRAC units, CRAC, computer room air conditioning units. Sometimes you'll say Liebert units. Probably some of you have heard that term. Liebert's a brand name. This has got a cooling coil in it and a fan, and it blows air down into this raised floor system, just like kind of what's happening here. And then we use the raised floor system as a plenum to distribute up through perforated tiles. So we blow the cold air right into the cold face of the servers. It goes back. We have warm air that eventually makes its way back to the return air inlet of the CRAC unit, and it gets cooled back down again and blows in. So in higher densities, it just altogether requires a lot of energy to cool that large volume of air. And there is a practical limit to where it basically doesn't work. It may cool, the bottom 3 servers or maybe the bottom third of the servers well in a rack, but up at the top, those servers up high are going to see some problems. They're not going to be cooled effectively. So that's led us to changes in the data center where we start to have containment systems where we use additional material to contain the air and start to separate the hot from the cold to increase the cooling efficiency. One thing without containment that happens, and this is what data center operators are trying to avoid, is this concept of hot air bypass. So I blow the cold air in, it comes through, but some of that heated air, because there are fans in these, every server, every hard drive disk unit has a fan in it that's helping to blow that air through the unit from the cold side to the hot side. There will be some bypass, and that bypass reduces the efficiency of the cooling method and can lead to overheated IT equipment. And IT equipment that runs too hot doesn't necessarily perform its computing duty as well. So we've tried to, operators are starting to want to avoid this bypass condition as air volume, air exchange rates have went up, and rack densities have went up. So they go to aisle containment systems, and this is ultimately where we're going to spend our time talking about the rest of this presentation and the challenges with it. So there are cold aisle containment systems and hot aisle containment systems. Let's break those down just a little bit. Cold aisle containment systems, we have our aisles, or our racks arranged to have the cold faces facing each other. We'll put a door on each end and then some sort of roof over top of it, and we'll have the same air distributed under the floor. Generally, a lot of times that way, it'll blow up through perforated tiles in the floor inside the cold aisle, and then out through the hot, into the room. And because of those partitions, there's separation between the cool air and the heated air, and then that heated air goes back to the CRAC units and starts to cycle over again. One thing that one of the things I've found funny about this is, if this is a pretty efficient way from an HVAC perspective on how to run your data center, but it's not a very comfortable way. Like, the only cool spaces in the data center are inside those contained aisleways. But if you're if you're an executive and you're building a new data center for whatever fancy business you have, you don't necessarily like this type of situation for your data center, because it's always hot, and you sweat in your nice dress shirts and those types of things. So this is not necessarily the most comfortable way to do aisle containment as far as creature comfort. What is more comfortable is this hot aisle containment, where you blow the cooling area or air into the room, which is more comfortable for people, and then it sucks through where the hot faces are facing each other, and then we actually duct in some way. Like here, they're using clear clear plexiglass and some aluminum framing to duct the air up into a ceiling plenum, and then the separation is the ceiling really between the room and the ceiling plumbing to get that air back into the crack units, which the crack units are then ducted up into the ceiling to get that to happen. You can kind of see that in section view over here. There were two variants, and you'll sometimes see these in data centers. These are hot air chimneys. This is sort of a form of cold aisle containment, hot aisle containment. It's just an individual duct, more or less, from a rack to take that hot air up and out into the ceiling space. You'll see in-row cooling. It's a lot framed just like that cold air with a door on each end and a roof. But then there's a cooling unit like a crack unit right there in the I guess taking up a space of one of the racks, and it cools air and blows cold air out, and it's drawn back in by the fan and by the little fans inside of the servers. And that's one way we recirculate and heat. So just different variations. A lot of it's doing the same thing. I don't want to spend much more time on this HVAC idea, but the point is, from a fire protection perspective, there are physical separations in the room that HVAC designers are taking advantage of to to cool more effectively. It's those physical separations that we need to deal with for fire protection. Some of those physical separations are fixed infrastructure things that purchased systems, a lot of extruded aluminum fixtures that help give us framework to lay in plexiglass or other materials. We can have doors, we can have nice walls up to the ceiling, but more rigid things. And then there's sort of the cheaper way, plastic strip curtains. It's people will talk about like going into a meat locker or a freezer. There's strip curtains there to separate the cold air from the warm air in a freezer. Well, this is the same type of material, and they're affixed to the ceiling in different ways. A lot of times they're clamped in some sort of aluminum extrusion up at the top. Aisle containment. This is important, as you're if you're managing existing facilities and consulting for them. Aisle containment could be included in the initial design, planned for, accommodated for. It could be retrofitted into an existing data center. This is, very common. There's a lot of data centers out there that are underprotected because there's been aisle containment systems retrofitted into them, and not, there's not been accommodations for the fire protection systems because of that, or modified over the life of the data center. It's going to do a little bit here, a little bit there. We've got a couple racks that seem to be getting too hot, so we'll hang some strip curtains here and start to see if I can address some of the bypass and make it better. Those are some of the things that happen in existing data centers to affect the fire protection. So, in fire protection, there's really three systems that aisle containment systems can affect. Sprinkler systems, clean agent like FM200, Novec, or Sapphire, or whatever clean agent system you may have, gaseous systems, they can be affected, and smoke detection. Those are the other things that can. Those are the three systems that are primarily affected by aisle containment systems if they're added to the data center, and not, these other systems are not addressed because of that. So some of the challenges that these units create. So we're gonna talk about the challenges, and then talk about what the codes now, NFPA 75 and NFPA 76 for telecommunications facilities say about these things. That one challenge is the obstructions, and those obstructions, whether they're vertical obstructions or horizontal ones, they can obstruct the sprinkler spray patterns in the room. They can obstruct smoke detection, coverage, and spacing. They can obstruct clean agent nozzle and how the agent is distributed and coverage in the room. For spray patterns, you know, we typically, you know, we're designing these systems to NFPA 13, but when these systems get installed without regard to the sprinkler locations, you know, we can break some of the 13 rules for obstructions, whether you know, the code is going to wind up saying now, you know, we have to make accommodations for this. We either have to move the sprinklers or not install the partitions. There's different ideas for that. Nozzle coverage on sprinklers when we or on clean agent nozzles, you know, coming in and adding these things can impact the coverage of the nozzles in data centers. We worry about gas being able to get to these new volumes that the aisle containment systems can create.
So how does water mist affect that, Lee?
Water mist is really the same as sprinklers. If we're using water mist in a data center, there are coverage rules, not so much in NFPA 750, but they will be there in the manufacturer manuals on the clearances that those nozzles need to have to be able to make the right kind of mist.
Okay.
And it's largely the same problem as what we've got with sprinklers. Let's see, clean agent. Now, the other thing on clean agents here is clearance. You know, clean agent nozzles need 4 to 6 feet of clearance from the nozzle before they hit a solid surface to make sure that all the agent flashes to the vapor phase to build an extinguishing concentration within an acceptable amount of time. So this is a little bit longer discussion, but since this is an FSSA presentation, I got to talk gas just a little bit. The clean agents, FM200, Novec 1230, or Acaro, or you know, HFC 125, Acaro 25, those agents, when they come down the pipe, they're in two-phase flow. Okay, some of they're stored under pressure as a liquid. Okay, they condense to a liquid when we bring the pressure up in the tanks, and so some of that agent going down the pipe is in its liquid phase, and some is in the vapor phase. When it comes out of the nozzle, when it finally exits the orifices of the nozzle, some of it is still in that liquid phase, and it takes a little bit of distance for it to flash to vapor. And so in the vapor phase is how we build the extinguishing concentration to put out the fire. If we have obstructions within, you know, too close to the nozzle, what we risk is something called frosting or splashing, you know, depending on which company talking about it. They're talking about the same thing, but basically some of that liquid agent hits that vertical surface and then stays in its liquid phase for longer than it would if it was just flying through the air with that clearance. So that's, you know, in a data center where this was not accommodated or we were not anticipated, you know, you put in a new containment system and we can have splashing issues with our clean agent nozzles. Inadequate obstruction, automatic obstruction removal. So there are the companies that first started selling aisle containment systems to data centers weren't stupid. Like, they realized pretty quickly that what they were doing, their products were having a impact on fire suppression. So they tried to have means for automatic removal. Most of the time they used fusible links. Okay, so they would basically make attachments, and this is a great picture here, this one all the way to the right. They would make attachments to the track on the ceiling using fusible links, and you know, they're UL listed. They're made to melt at a certain temperature. I mean, it was it was like engineering halfway done. You know, good job, good attempt, but it's not a complete solution. Now they'll say, and this is one of the cut sheets out there. Hardware is designed so that curtains fall away in the case of a fire, allowing sprinklers full operating range. Another quote, should an event occur that would set off a water sprinkler system, the UL listed fusible links will melt and fall harmlessly away from the ceiling down to the floor. So like they used language that made us feel good, like UL listed and, allow the sprinklers full operating range. But the problem is in that case, you've got to have a big fire to melt all those links and get those things to start falling down, which is not good in a data center. So the question is, as you have these links and they're about 4 feet apart in most systems, how big a fire is it going to take for all of those links to fuse and that track to fall down to the ground and let the curtains fall there? Another thing is clean agents. Clean agents are meant to extinguish or activate early when the fire is small using smoke detection. Well, we're not going to be building up heat to the point that we can melt any of those links. So, we don't that methodology of using the fusible links doesn't really address clean agent systems. Kind of challenge 3 here, multiple containment volumes. All of a sudden we're taking one large space and making smaller volumes. How do we deal with that? How do we deal with it from a clean agent concentration development? Smoke detector coverage. Now there's a volume within a volume. How do we cover that? And can the volumes break up our cross zoning? So, in a lot of suppression releasing, we use the idea of cross zoning, where it takes multiple smoke detectors to detect smoke before we'll release a system. And can these new obstructions affect that? So, and this is actually somewhat controversial. NFPA 2001 says that each volume, room, and raised or sunken floor to be protected shall be protected with 3 things: detectors, piping network, and nozzles. Detectors, piping, and nozzles. Well, so aisle containment systems make new volumes inside the larger protected space. So basically, what do you need? Well, every time you have like this cold aisle system, you need detectors, piping, and nozzles inside of it. That's a big challenge in a lot of situations, and it can increase the cost of the installation, but yet the code says that. Cross zoning here, this is, the orange detectors will be on zone 1, and if we had an old zone releasing panel with 2 different conventional zones on it, and the blue one zone 2. Once all of a sudden we put those partitions up, in the smoke, smoke's not going to hit both of those until the smoke gets worse, and it's going to delay the release of it. So that's another challenge that containment aisles can affect. High temperatures, challenge 4. So because of the increased rack density, more power, more heat given off, the hot side of the servers, the hot aisles have gotten hotter in these situations. It can impact the sprinkler temperature rating that may be there, the smoke detector operating range, and it may affect the clean agent concentrations because those are affected by the operating temperature. Challenge 5, high airflow velocities. What essentially happens or has happened in a high density data center with aisle containment, we've basically made spaces continuous ducts, and the smoke detectors are only rated to so high of velocity. So like most are high in air velocity. So most smoke detectors, when you look at manufacturers' listing sheets are listed to around 3,000 feet per minute. Well, we've done some math on some of the data centers that we've been involved in, and some of those situations, we can exceed that in some portions of the system, meaning that the spot smoke detectors, if we're using photoelectrics, they may not be rated for the air velocity that's moving by them, which then makes their effectiveness questionable. It can also affect clean agent distribution. We don't have a lot of data on how clean agent moves in these higher flow environments. And so with these 5 questions, a couple things have been done. One thing, and we'll talk about this at the end, we'll talk a little bit more about the detection side of things. The Fire Protection Research Foundation did a research project for high smoke movement and high airflow conditions. And so that was like a 2-phase study. After phase 2, there was kind of enough information for the NFPA 75 and 76 technical committees to write in new information into those standards to address those high airflow conditions. It didn't. Most of that research landed in new requirements in those areas. It didn't really change NFPA 72 much, and we'll talk about that kind of at the end. Another thing that we'll talk about towards the end here is that higher flow and agent distribution. There's currently, the FSSA is performing a research project on its own outside of the Fire Protection Research Foundation. We did that because it was just, we've got the gas, we've got the hardware. It was cheaper, frankly, for the membership to pay for a research project through the FSSA than to go to the Fire Protection Research Foundation. So there's currently a project, to research what happens to agent under higher flow conditions, and that eventually, I kind of have my guesses where that's going to go. That's going to give us the ability to put new requirements into the code and maybe address some of these challenges in a different way than we're addressing them today. But until then, we have new requirements that were written and are put into NFPA 75 and 76 in the 2013 edition. We're past that now in editions, but it's all the same information. If you look in 5.6, there's aisle containment and hot air collar systems for information technology equipment. There's 8 new requirements that are part of that. So we'll go over those. First off, the first requirement is that aisle containment system materials should be constructed with fire retardant materials. Okay, so they should, since they're all kind of in this, they're not plenums, but they're in this sort of plenum environment. The requirement is that they need to have a flame spread index of less than 50 and smoke development index of less than 450. So it's not as strict as plenum rated materials, but there is a requirement there now. So there's something for containment system manufacturers to now make sure that their products meet inside of the fire codes. It's very clear in the new requirements that these areas are not classified as plenums, so you don't have to have plenum rated cable, and that's a big deal in data centers because all of the low voltage cables, whether it's network cable, fiber optic cable, or power cables to the individual pieces of IT equipment, a lot of those manufacturers don't make plenum rated cables, and if you did have to purchase plenum rated cables, it would significantly increase the cost of data centers just because of the amount of wires. So NFPA 75 is clear about that plenum rated construction materials are unnecessary. Inside of areas of aisle containment, I kind of need to classify that. NFPA, third thing, equipment should be rated for the temperature maximum of the hot aisles. Now, there's going to have there's the HVAC engineer is going to have to help define what that maximum temp could be, and that a lot of that depends on the inlet temperature to the servers. How cold are they running the room? But hot aisles normally, normally they can have temperatures approach 120 degrees. If they exceed 150 degrees, or excuse me, if the HVAC fails, the heat coming off the servers, those hot aisles can quickly reach 150 degrees Fahrenheit. Smoke detectors, if you look at, manufacturer cut sheets for System Sensor or Siemens or Simplex, most smoke detectors are rated for either 100 degrees Fahrenheit or 120 degrees Fahrenheit. So we can exceed those temperatures, especially like if in some more modern data centers where there's less human interaction needed. If you go in a data center now today, the people working in the data center doing software upgrades on the servers or swapping out equipment, they're wearing shorts and t-shirts. It's hot in there, and that's on purpose because they're running their data center to increase the inlet temperature, and we're picking up about 20-25 degrees across the server as the air passes by, and the equipment's being made so it can tolerate that higher temperature. So it can no longer does a data center have to be as cold as a meat locker. For energy efficiency, the equipment can withstand those higher temperatures, which on the hot aisle side is raising the temperature up and giving us a problem with our conventional equipment. And then sprinklers. Most data centers have ordinary, quick response sprinklers with temperature ranges of 135 degrees. It's possible to get so hot in those rooms that we may fuse the sprinklers. So it's just, again, something else that we need to think about, and this is part of the code that addresses it. Number 4, a retrofitted aisle containment. When you retrofit aisle containment, the code says you need to consider existing fire systems. So it's kind of like a retroactive thing. You need to go back and address the existing systems when you're putting in aisle containment. You've got to maintain compliance with the applicable codes. So that's mostly we're talking about NFPA 13 for sprinkler systems and sprinkler spacing, obstructions, and NFPA 2001 for clean agent systems, obstructions. And of course, as you asked, Steve, if there was a water mist system, you need to address that too. Evaluate the design, modify the installation as necessary, and then have a re-acceptance test of the installation. That's what the code says to do. Number 5, sprinkler systems, you have to address the obstructions. This should be pretty self-evident to this group. Follow NFPA 13 requirements and modify the sprinkler system as necessary for those obstructions. This is pretty detailed in the code. You have to have automatic obstruction removal. Like if you're going to use fusible links and you're going to say it's automatic obstruction removal, if that's your method and you're not going to modify the sprinkler locations and you're going to depend on those the strip curtains dropping down or whatever thing, the obstruction being removed under fire conditions, it must have these 5 things. Okay, the system must be removed by smoke detection. So fusible links, thermal detectors are not allowed. It has to be removed by smoke detection early in the timeline of the fire. Second, releasing devices must be listed for the purpose. So, this device must be listed to release your obstruction in your system. So, there's some mismatches that can happen out there if you're just buying the same fusible links that you would be releasing roll up doors with, or roll down doors with, or fire doors with in other occupancies. So there, it's got to be listed for that purpose.
Hey, Lee?
Yeah.
Real quick, is any of this retroactive? That was a question that just came in.
Absolutely retroactive. I mean, that's this one right back here. Number 4, and in the code that's 6.77, where aisle containment systems are installed, the existing suppression and detection systems shall be evaluated, modified, and tested as necessary to maintain compliance with the applicable codes and standards. To me, that means retroactive.
Okay, thank you.
Yeah. Third here on the list, remove all obstructions for the entire suppression zone. So that basically means that if you're going to drop the curtains, you're not just going to drop it on one hot aisle way. You're going to drop it on all of them. Okay. Fourth, the removal shouldn't impact egress. Okay. So as I need to exit the room, I don't need to be jumping over piles of curtains or getting hit in the head with them as they're dropping. You know, that's pretty, what that is leading to is some of the manufacturers that are using, they're meeting this by using electronic thermal links, and it's a fusible link that can be either activated by heat or a little bit of electrical current, and the electrical current causes a chemical heater to start activating, and it warms the device up and breaks the connection, allows that to fall down. And so those are the devices that were doing that. But as they fall down, then there's typically cables that keep that aluminum channel from falling all the way to the ground. And usually they're 18 inches high, because that's the obstruction rules, is, you know, items within 18 inches of the sprinkler can't, you know, are an obstruction. So most of those cables are 18 inches long to allow this to fall down 18 inches and stop. And then finally here, it doesn't lower the intended level of protection. So, you know, that's a little more abstract of a requirement, but basically, you know, we don't want to make the situation worse when we release and try to do automatic obstruction removal. So that's a big concept there. You know, if you've got some questions, come back and ask me on that. On gaseous systems, it says, the code says that you should build required concentrations throughout the protected volume and modify the suppression system as necessary. So if I'm coming back in and adding in this cold aisle containment system, well, I need to build concentration throughout the entire protected volume. So this is a new volume inside the room, and I need to make sure that I build concentration in it. If we're going to not modify the system and not drop nozzles into that, and we're going to depend on automatic obstruction removal, then basically it's the same thing. Remove by smoke detect, same thing as sprinklers. Remove by smoke detection. Devices must be listed for the purpose. Remove prior to agent discharge. That's the only thing that's different. Remove all obstructions from the entire zone. Removal can impact egress, and it shouldn't lower the intended level of protection. So, you know, that's the only, that's why if you're going to remove things in before gas dumps, instead of, you know, modifying and putting nozzles in the new volumes, that's what you've got to do. Now, there's products that are meant to do this. I go back a slide here. This is a cold aisle containment system roof, and it's basically it's like a you know, a roll down shade. You remember those roll down shades that'll come down out of a roll and cover a window? Well, this is the same thing, but horizontally. There'll be a releasing device at the end. It can be tied into the fire alarm system. It'll activate release, and this thing will, via a spring, it'll just roll up into this box at the end and open everything up. That's their systems like this, and it's maybe on this next page. They can have louvers that automatically spring open once released. There's a number of ways to get gas in there without modifying the system. What I typically see, though, in my professional experience, is that the data center operators don't want to spend that much money to build their containment systems. They would rather have a simpler less extravagant system, and therefore they're having to modify the suppression systems and the sprinkler systems. This is a big problem for the gaseous kind of industry. And so this is one of those places where we've got some research that is going to be happening. It was supposed to be done this year, completed this year, but it was underway at the beginning of this year, and COVID has slowed it down. Ultimately, we have a data center mock-up built at one of the suppression system manufacturers. It's pretty neat research. We have 3 different makeups of the data center that we can arrange it in. We have a few donated used crack units that we're using to help blow air around the space. We're doing a number, we've got a bunch of concentration meters that we're setting up, and we're arranging the suppression systems in different ways. We're doing a lot of testing with total flood CO2 and using CO2 as a surrogate gas for FM200, because frankly, it's all, it's a lot cheaper to use CO2. So we're fine tuning things with CO2, and then we have some prove out tests that are part of the research plan where we are actually going to discharge FM200 or Novec or whatever donated gases we're getting. And then we're basically trying to answer the question, when the airflow is continuing to run, that's another thing that's happening. A lot of data centers don't want to shut down their HVAC anymore. They just want to keep the HVAC blowing and ride through the event. And so can we use that, take that as to our advantage for better, faster agent distribution and not install nozzles inside the contained aisleways? And so that's what the research is ultimately trying to answer. I'm pretty confident that it's going to show that agent moves a lot better than what we expected, and frankly, it moves really good under high airflow conditions, and we don't have to we can simplify our systems and not necessarily have to put nozzles in every contained aisleway. But until we have that research and have it written into the code, we need to continue to do that. But I am hopeful that, I would imagine, at this point, sometime mid 2021, we'll have the research data and have a published study from the FSSA on this research project. On smoke detection performance, and this is kind of the other big research project that happened on high airflow, smoke detection and high airflow. There are some really high airflow rates that are possible in portions of a data center that has aisle containment. We used to use this table. I don't know who's familiar with looking at this, but this table out of NFPA 72 is the smoke detector spacing based on air movement. And so you can look at how many CFM of air is being blown into a space with the air handler, and take the volume and calculate the air changes per hour. Most comfort cooling, like what in your commercial office buildings, we're running about 6 air changes per hour, and the code says, hey, smoke detector spacing is 900 square foot per detector, so 30 by 30 spacing on your detectors. But as the air change rate goes up, we dilute the smoke faster, so the spacing of the detectors has to get tighter and tighter. So the maximum that this this chart goes to is 60 air changes per hour, and says to use 125 square foot spacing. So you take the square root of 125, and some of you are probably better than head math than me. I think that's like 11 feet and some change. So in a normal 2-foot ceiling tile grid, we usually space detectors at 10-foot spacing, and that's pretty darn tight. And to To go much tighter than that, we don't have a lot of room for lights or sprinklers or anything in the ceiling. And so we're kind of limited practically at that 125 square foot spacing for detectors. What's being calculated up there, there's 500 to 1,000 air changes per hour in portions of these data centers that have high level containment. Big time dilution of the smoke, high air velocity movement, but more than our normal detectors, more than the code really allows us to design to. So we needed better guidance for design. The Fire Protection Research Foundation, was approached, and they did this two-step research project, and we got information out of it. Frankly, this is what is now in NFPA 75 for smoke detection. So to provide early warning fire detection, smoke detection is required in a data center at the ceiling level throughout the IT equipment level. So we're not getting rid of that. We've got to have smoke detection there. We need to have it below raised floors containing cables, and that's what it says. Just if you've got a raised floor system and it contains cables, then it needs smoke detection.
So Lee, when it says containing cables, right?
Yes.
It doesn't matter if it's plenum listed or non-plenum listed, correct?
Correct. It does not. That plenum rated comes into play whether or not you need suppression under the raised floor. Like, so gaseous suppression, when you're talking about that, well, actually, we in NFPA 75, it always says like you need to have suppression when these things are there, when you're following the prescriptive requirements out of it. Well, if you have non-plenum rated cables in a raised floor system, then you're going to need suppression. And that suppression could be sprinklers, gaseous suppression, or water mist. And it kind of always gives you those three options. But as far as detection, this is different. You need smoke detection in any raised floor containing cables, plenum rated or not. Okay. In the exhaust, third point here, in the exhaust return air stream where aisle containment systems are used. Basically, what that Research Foundation project showed is that at early stages of the fire, the HVAC air patterns influence the smoke movement much more than the buoyant forces of the smoke from the fire would. So most incipient fires in a data center where smoke is being produced, that smoke is going to be, because of the high air change rate and a large amount of cooling, that smoke's going to be cooled down quickly. Its buoyant energy is not going to be enough to overcome the HVAC air patterns. And so what the code says is think about how the HVAC moves air in the space and put detection along that air path. And so in the exhaust or return air stream, as smoke has moved past the IT, or air has moved past the IT equipment, and that IT equipment may be having the fire, then somewhere downstream of that, that's where you put your smoke detection to try and capture smoke that may be coming from the IT equipment that we're trying to protect. Okay, does that make sense? Fourth point, in the return air stream, where the above ceiling area is used as a return air plenum, you should have smoke detection. So basically, if we're taking air up above a suspended ceiling to use it as a plenum to get it back to the air handling equipment, then we need to have smoke detection up there. So that's where it's suggesting it. And then finally, we need to have smoke detection located to operate required smoke dampers above the suspended ceilings and below the raised floors if that air is being used to circulate air or those dampers are being used to circulate air to other parts of the building or where suppression systems may be deployed. So basically, we've got to have smoke detectors so that we can operate dampers if it's part of the whole sequence, okay? Whether it's, limiting smoke spread out of the data center or into the data center, or shutting down dampers so that the suppression system works. You've got to have smoke detection to do all that. And so just to show you some of those points graphically, those little green dots are places that we would have smoke detection under NFPA 75. In the raised floor containing cables, along the path of air, exhaust or return to capture smoke there. This is one of the best places to capture smoke in an operating data center, is right here as the air goes up into the ceiling plenum. The guidance for VESDA is a great product to use. Air sampling smoke detection, specifically VESDA. And what we do is we put a pipe right down the middle of the contained aisleway, and we put a sampling hole in it every 6 feet, and that meets it. We've had successful smoke captures under thermal conditions. That's a great way to do it, and that's what's recommended by Extralis for their VESDA product. Up in the ceiling, if it's being used for air return, and at the ceiling point. So this is sometimes overlooked. I believe it or not, people don't see the forest from the trees. That they'll sometimes forget to call out for detectors of the ceiling, and the whole point is, hey, if we shut down the HVAC, normal buoyant forces are going to be there, and that's where the smoke's going to move. We need detectors at the ceiling, even though when the data center is operating, that's not going to be the first detector that detects smoke. It's going to be probably one of these detectors along the path of the airflow.
So Lee, you mentioned about dilution. Does that how do you compensate for the obscuration percentage for activation?
Well, it's air sampling is just one of the technologies that is two things. It was shown to work through the Fire Protection Research Foundation results, and it's just been shown the telcos, AT&T, Verizon, Sprint, those companies have used air sampling for years, and they never really publish their data, but they catch multiple smoke events, double-digit smoked events, and around 50 or so a year using air sampling at return air grills. That was really in those code discussions, the telcos guys, their experience came out very strong, that they have used as a practice putting air sampling at return grills in their facilities for years, and they catch smoke events that way, and they catch them early, and they get to address them. And it's not their smoke detectors, their spot smokes that help them catch fires in their building, is their air sampling. And so they, as far as sensitivity of the holes, NFPA 76 has that guidance on how to set up for sensitivity, and I think that's now in NFPA 75 too also. But basically, what should be the fire alarm sensitivity of a sampling hole and basically we're approximating what a spot smoke detector would be. I think it's like 1.5% obscuration at the hole, which when you dilute the air going back through an air sampling smoke detector, you actually have to be more sensitive than that at the detector than what you are at the hole to achieve that approximate sensitivity at the hole. So one good way that we do that, whether your standard is you want alarm at 1% obscuration or 1.5% obscuration or 2%, whatever it is. You take that, you know that value, you count out the number of holes in your air sampling network, and then you divide that concentration by the number of holes, and then that gives you a concentration value to use on your air sampling detector. That's what you set it up. That's basically that's the method that Extralis recommends now, and that's I hate to give away too much information, but that's the way that AT&T wants their detectors set up, and that's basically what Extralis says for everybody now. You take the target hole obscuration divided by the number of holes, and that's what you set the alarm threshold at in the detector. Did that answer what your question was?
Yes, thank you.
Okay. This is a cold aisle containment system, so just applying these same, smoke detection requirements to cold aisle containment. In the subfloor, if there's cables, as the air leaves the servers, so on the server face, that's a good place to do it. At the ceiling, those are the main three. Now you see some other ones here, because this is frankly out of an Extralis white paper, so they want to sell more air sampling, so they're showing it at the crack units on the incoming side and the leaving side. But that's okay. One thing that you don't see on this, and this is kind of important, is you don't see detection right here at the ceiling on the cold aisle. That there was David Quirk was a fire protection engineer for Verizon. He doesn't work for them anymore. But David, when he did when this all was going on, he was the head fire protection guy for Verizon. They did some CFD modeling, and basically what they showed was right at the top here on a cold aisle system is dead air, and smoke's never going to go there. So it's a waste of money to put smoke detection to the top of a cold aisle. Even though the code says if this is a contained space and you've got gas, you need to have detection, piping, nozzles, all those things it says, but this is generally a bad spot to put detection because it's just dead air. You're not going to blow smoke by it ever, and it's just a waste of your money. So a couple hints there. That's my presentation, guys. It was a lot there, and also very specific about data centers. Anything else that came to mind that I can answer?
I think the only question I have, Lee, I noticed you went over a lot of requirements that you pointed to a section you said that would imply it's retroactive. Have you had anyone argue that because it doesn't use the word retroactive, that the requirements are not implemented retroactively?
Oh, I've had a lot of people just straight up ignore it, Rob. It's happened to us at least 5 times where we have went into a data center. We've installed a gas system and all the detection and control for it. We've had the fire marshal out and final the system, and we go back 6 months later for the first inspection of it, and there's aisle containment all over that place.
Wow.
And then now, nozzle locations are messed up, sprinklers are messed up, detection's messed up. That's happened at least 5 times in the last 5 years. There's very little consideration of fire protection that happens here, and I think that's one of the big problems. These are voodoo spaces to fire marshals, so This is a code that, it's an occupancy-based code. Fire marshals don't run across this type of occupancy often. They're not going to know this type of specific thing, so they're not going to be able to enforce this real well in the field, and they're not enforcing it well. It happens, and that's just our company. I know it's happening, a lot out there for just in general in the United States, let alone the world. So in another place, just as we're as I'm complaining about the data center market and its casual approach to fire protection, this same thing's happening with lithium ion batteries in battery rooms running where we used to have lead acid batteries to run the UPS systems. There's the big companies out there. Vertiv was one of them. Schneider Electric's another one. They're going in and they're putting in lithium ion. They're tearing out the lead acid batteries and going and putting in lithium ion ones. And there's no accommodations for the fire protection. Frankly, NFPA 855 is not really addressed that UPS condition well. There's a lot of my NFPA 75 committee is trying to gain back that control over UPS systems and data centers, which we've kind of lost to 855, and they're more focused on the energy storage applications and not the UPS applications. So we've got these big rooms in data centers. We all know that there's fire protection problems with lithium ion batteries, and they're just coming in and doing this, and they're not addressing fire protection. And I'm not even totally sure what the fire protection requirement should be yet in data centers for lithium ion installations. But I'll tell you what, it's got to be something, Yeah. So, and that's going to be another place where we're going to have to write it as retroactive. We're going to have to go out to the HJ community and let them know that this needs to be done. And there's going to be a lot of mad data center operators that are not going to want to have to make adjustments. But I'm telling you, what they've got there now is not enough. And if they have just one rack burn up, they're going to be a world of hurt for what fire damage is going to happen in their data center, what smoke damage is going to happen in their data center.
So are the new servers and data centers just as susceptible to smoke damage as they were previously?
Oh yeah, absolutely. So one thing that's happened, in server technology, there's kind of been this little bit of change. There's been a change. When we first started talking about computer rooms, server rooms, that equipment was really expensive, and that's why we protected it with halon and put a lot of gas into data center spaces, and that became popular because the equipment was so expensive. Well, then the equipment got cheaper, right? As we went on and built more of them, we got better technology. Servers became cheaper and cheaper. They almost became throwaway. Well, now there's this new thing that's happened because the computing loads are higher and there's this demand to be more energy efficient. You don't want to be paying for a server to be running and sitting idle while the application's not being used. So what they'll do is they'll have this more expensive, higher class computer, and they will turn it into a virtual server. So they'll partition the computing space in that server and basically allow it to run multiple applications at once, so that when the accounting department is needing the accounting work, that software, it spools up and it eats most of the computing brain power that server has. But the shipping department's not shipping at the time, so the shipping software is not being used. So it's kind of sitting there idle and not consuming a lot of power at that time. Well, it takes a pretty expensive computer to do that virtualization. So now the cost of the computers the total build out cost of the IT equipment in those racks has went up, substantially. Now like a single rack can hold $3-4 million worth of computing equipment. So all of a sudden the loss equation has changed, and it's more, we've seen less gas go into data centers, except for now with virtualization. Well, now the cost of that equipment has went up. So there's not only is the data loss expensive, but the equipment loss is expensive if you have a fire. So we're seeing this kind of change in the loss equation where it's making gaseous systems become more reasonable from a loss control perspective. We can afford the cost of them because what we're protecting is more expensive. So
kind of sounds like what you need to do if they're not adequately protected because of changes they've made. You need to drop a dime to their insurance company instead of the fire marshal.
Well, yeah, and most of them are self-insured, and it's tough. There's different types of data centers. Like if I'm a big cloud provider like Amazon, Microsoft, Facebook, I've got multiple data centers that I can shift my computing load to if I have a problem. Facebook has been pretty forthcoming in some of the big, kind of explosions that they've had. They had a big explosion at a data center in Sweden. And it was in high voltage cables and splices that ultimately was a problem. The splices weren't done correctly, and it resulted in this explosion. But they've got another data center in 500 miles away, ready to go, and just that computing load just moves over it. Some people may see a regional degradation in the speed that it takes to get their favorite cat video, but who cares? It's a completely different deal. If I'm a data center for a specific business, I don't have all that backup. If enterprise data centers have a different level of risk. Like if that's my only site, well, then I need to protect it like that. And then there's stuff in the middle where it's co-location data centers, and I build a data center and I rent you space in it. And then you may value the fire protection. So if you want the fire protection, yeah, we'll put it in your space. We'll just roll it into the rent. If you don't care, you just want the space, well, then we'll just put in pre-action sprinkler and move along. So there's just a lot of different ways that data centers get built, get sold, get rented, and all of that is part of it. One of the things I'm really passionate about, and this is outside of FSSA, so this is now Lee's opinion time. I'm really thinking about data centers as they're going to change as they support a couple things: driverless vehicles, driverless vehicles, whether they're humans or they're flying around us. If you guys have probably seen some articles on the driverless semis or the medical drones that help fly medicines around, that kind of stuff. I think those applications are super critical, and all of those applications are going to be supported by data centers. I am, really wanting to make sure that data centers that support those applications have the highest level of fire protection so that they don't go down. Like I just think for public safety, if I've got a self-driving car and I'm riding along in it, and the data center that's helping to support that application has a problem, I want it to, the problem to go away as fast as possible so I don't crash and die. The computing infrastructure that's going to help that is something called edge computing. And that's going to be a lot of little data centers close to the applications that are using that computing so that they have less latency, or they're low latency applications, meaning there's less lag because of distance for data transfer. And I think those edge computing centers that are, helping more and more autonomous vehicles exist, they're going to need fire protection in a big way. And frankly, it's going to be fairly easy to deploy gaseous systems in those situations because they're generally small spaces, and the smaller it is, the cheaper gas systems are. And frankly, the harder it's going to be to deploy water-based systems, and the more of a headache water-based systems are going to be. So those are some changes that I'm going to, really starting to talk about, in the 75 committee. So anyway.
Interesting. So there's a movement where they're going to more clustered server units for data transfer to minimize the distance for latency and lag.
Yeah. So like after the cloud, like the cloud is, you don't know where your data is stored. It's in this far off remote data centers, probably in several data centers at once, but you don't know where it's at. You just give it up there. But you go to the cloud for in the edge concept, you go to the cloud for long-term storage of data and for big data analytics where you're looking for patterns using AI and whatever. But for as far as real-time decisions on, input to devices, to IoT sensors, that has to be, that computing use can't necessarily be in the cloud. It's got to be very near the source so that you don't have the latency problems. And those smaller data centers close to the source are where, there's a lot of opportunity for humans to get hurt if those data centers go down due to a fire.
Interesting. Well, that was a really good topic. Yeah, go ahead, Steve.
So Lee, do you see the government following the industry, or is it separate still? Because there was a time when data centers were done differently within the government.
I think they still are, frankly. I mean, I think they're done. And it also depends on which sector of the government it is. I mean, we out of some of the labs, the national labs, we see a different approach than what we see with the 3-letter agencies, that kind of stuff. It's just a different. We don't do a ton of government work, so I don't think I'm totally qualified to speak about this, but I can say that I see a difference in mindset on the few people that are on the NFPA 75 committee from the government. They just have a different mindset about fire protection in the data center than other stakeholders. So.
How do you mean different mindset? How's it different?
They want the lowest cost option. So, more or less. Not always like the highest level of protection. I think they want the lowest cost option.
So they're basically willing to accept risk to a certain degree.
Yeah, I think that's another way to put it.
Yeah. I know the DoD, I've read some articles where DoD is trying to consolidate data centers in other areas. And I was just kind of wondering if, we were going down the hot code aisle and et cetera, So I appreciate it. Thank you.
Thanks.
Yeah, I know Savannah Riverside updated their server capabilities when COVID kicked off. And I don't think fire protection was ever consulted when they made those improvements and changed out their equipment for higher bandwidth and to allow more employees to access the site remotely. So that does actually raise a pretty big question within the government sector. What's being done at the different sites that it may not actually be under the current requirements, NFPA 75 and other risk mitigation strategies. this is actually a really good topic, man. I had not something I really thought of. So thank you very much for speaking tonight. This was great.
Well, thank you. It is a very niche area of fire protection, but you know, I enjoy it, and you don't think about it much because there's not a ton of fires. When there are fires, you know, they're hidden quickly. You know, since they're usually in data centers or mission critical installations, when those companies want to get things back online as fast as possible, and letting a problem linger for long is not in the business plan. So you just don't hear about data center fires frequently, but they do happen. Our company, you know, we're not huge, but we're really good sized. We respond across the country. How about this? We recharge cylinders at customer sites due to a fire related discharge 1 or 2 times a month consistently. So
Wow. Do you know what the causes of fire are? Is it typically just failure of the equipment in the server room? Is that the most common?
yeah, no, honestly, IT equipment is only around. Now this is all anecdotal, so excuse me, but we find about I have a graph that I use sometimes to teach it. By ignition source, when we're allowed to investigate what the problem is in the data center, most of the like a quarter to a third of the time, it's high voltage power distribution. Not high voltage, but you know, non-power limited. So anything above 50 volts power distribution to the IT equipment. That's along the path of power distribution. That's usually the cause. You know, another only about 10% of the time is the ignition source ever the IT equipment. That used to be more common. We used to have more power supplies burn up and that kind of stuff. But that equipment has gotten more reliable. I do have some examples of that. You know, I've got some pictures of a data center fire that happened in North Carolina. You know, you can see the back of the servers where the cages over the fan on the back of the servers have melted, but there's only like, you know, 2 melted cages, and then the Novex system discharged and put out the fire. So like, I mean, you see a little soot on the cables, but otherwise you get a foot away from the point of ignition and everything looks normal. You know, I mean, it was a very small event. We were frankly lucky to get pictures of it. You know, there's other things where surge suppressors have caught on fire. One of the common, we have a lot of smoke incidents caused by crack units burning up a belt. A motor will seize, burn up in a crack unit. It doesn't really result in a fire. It just is a smoke event. Capacitors on UPS systems in those will cause issues. We've had a few generator fires on diesel generators inside of the data center building, but that's not really in the white space. So, you know, those are some of the things that have happened. And then like the random weird stuff, like people having coffee makers in the data center when they shouldn't have them, like microwaves, that kind of stuff. We'll see that. And then there's housekeeping things like in your data centers, don't unpack IT equipment out of boxes in your data center. Don't bring that extra fire load into your data center. You know, have a separate designated room where you unpack servers and get them ready to be installed. Don't do that in the data center. So
that's a good point. Well, I know I've seen that in some of the data centers I've walked down where they're just staging stuff ready for installation, and it's all packaged on a pallet, you know.
Yeah. Oh, I mean, you know, if that would ever wind up catching on fire, that would be a lot bigger fire than if the racks caught on fire.
Right.
So, yeah.
Well, this was great. Did anybody else have any other questions for Lee? Going once, going twice. Well, Lee, thank you very much, man. This was really great. I really appreciate it. And like
Well,
I said, I
thanks for-
recorded this, so I'm going to throw it up on the website, and we'll throw up your slides as well, so they're available.
Okay. Thanks for asking the FSSA. We appreciate that. And Merry Christmas to you all. Happy New Year.
Merry Christmas, Happy New Year. Thank you.
Thank you.
Thank you, Lee.
Bye-bye.